Hello everyone, welcome back to my channel. In this tutorial, we are going to solve this thermal analysis case using salome meca. The problem is a two-dimensional stainless steel shown in below. This is our model. The dimensions are given here. Determine the temperature distribution. The left and right side are insulated. These two sides are insulated. The top surface is subject to heat transfer by convection. Here there is a heat transfer by convection. So the external temperature is 40 degrees Celsius and heat transfer coefficient is 50 watt per meter square into degree Celsius. The bottom and internal portion surface are maintained at 300 degrees Celsius. These surfaces maintained at 300 degrees Celsius. And the thermal conductivity of the stainless steel is 16 watt per meter Kelvin. Find the temperature distribution in this geometry. Now we'll go to software. I'll open salome meca. So this is my file. So just open the terminal here and put this command. It will get open. Salome meca, it contains both pre-processing, post-processing and solver as code aster. You can install Salome as a software separately and code aster also separately we can install and we can work in. This is actually inbuilt model to all. So first just go to geometry. First in pre-processing we need to model this geometry. So we'll start from 2D sketch and we'll build the face. So this coordinator, go to new entity, basic 2D sketch. I'm going to draw in XY plane. So point, absolute, just apply it. Now we have created the point. Now we can move into relative. From that we can draw the line. So this is 0.3. This small edge is 0.3. So just specify only the 0.3. Apply. It will create 0.3 line. Fit screen. See here. Then just go to the model, then vertical it is 0.2, again 0.2. Now in relative only the direction will only this position. Now we are in this position, we need to specify the value. If you are using absolute, we need to specify from the 0 position. So now we are in the relative, so just keep in the relative. Now this is 0, y is 0.2. You can see it here. Just apply. Now this line we need to draw. Now the y is 0, x is 0.2. Now y is 0, x is 0.2. Now you can see. Now again do it. X is 0, y is minus 0.2. Now we got this shape. Just apply it. Now go to the model. This length again 0.3. Now make it y is 0. This is just make it 0.3. Just apply. Now make it x is 0. Now y length, total height is 0.4. Just specify y is 0.4. Just apply. Now we just want to return back 0. Now x value is the total length 0.3, 0.3, 0.6 and 0.8. Minus 0.8, minus 0.8. Just apply. Now we can give sketch closer. What it will do, it will close the sketch closer. Now it is closed the sketch. Now we have done of modeling our geometry. I just switch on the axis. Now we have created the model in XY plane. Now select the sketch, go to new entity, build face. Now we have built the face to the sketch. Now just go to the model. Now we have created the model. Now we need to create groups to apply the boundary conditions. The first group is constant temperature boundary condition, these edges. And second group is convection boundary condition and top edge. So first go to right click, create group, edge group. Press the shift and hold and select one by one. Now we have created the edges, just add. This is the 1 2 3 4 5 edges, 2 3 4 5. Okay, now this is temp 300. Just apply this top edge, just add it. This one is a convection. I'm just giving conv, just apply. Then we can create one face group also. Just select all, face, plane plus. Now we have created all the groups. These two are insulation boundary condition. We need not to specify any boundary condition, means it is insulated. Otherwise we can specify constant heat flux is 0. That way also we can do it. So I'm just saving. Go to Vengat, pictures, code aster. So I'm just saving this file, save it. Now I have saved the geometry. Now we can move into meshing. So change this geometry model into mesh model. Now we are in the mesh model. Select the face one, mesh, create mesh. There are different ways we can mesh the geometry. Here I am going to use NetGen 1D 2D, NetGen 2D simple parameter. I am going to specify the local length of 0.08 008 or 08. Say OK, apply and close. Right click, compute. It has generated very coarse mesh. If you want to make finer, just reduce the element size. Compute. Now see, we have created very fine mesh. This is enough for us. Now just check the groups. Just hide this mesh. These edges we need to apply constant temperature. This top edge we need to apply convection boundary condition. This is complete element phase. Okay. Now we can save this model. Now we can move into aster study to create the setup to solve the case. Now we can move into the PPT. Material property thermal conductivity is 16, and this here the bottom edges are 300 degrees Celsius, and top edge we have a convection boundary condition. Now we are in the aster study. Now for this particular case we can use a wizard to create the setup. Right click, add a stage with assistant. The first one is linear thermal analysis. Here we can use 2D and 3D model. Just go to new. Next, this is not a 3D analysis. This is actually plain thermal analysis. Next, thermal conductivity is 16. Here you can check 16. Go to next. Imposed temperature on the groups. Constant temperature boundary condition. We have one constant temperature boundary condition, that is 300. We can choose it here. We can apply temperature of 300. Go to next. Do you want to add a stream on normal faces? This is nothing but surface heat flux. We don't want to add any surface heat flux because in our case we don't have any surface heat flux. Just give it no. Do you want to add volumetric source? That means volumetric heat generation is there. There is no volumetric heat generation. Just no. Go to next. Now we just want to save the file. The thing is, we are not completed a full case. We are just generating a dummy setup. From that we will edit and we will create the final setup. Result.rmed. RMED is the output file format for code aster. Now we have created the setup. It's not the complete setup. We need to edit this setup. Now we have read the mesh. This is actually a plane thermic analysis. Here you can see plane thermic analysis. Material is lambda, thermal conductivity is 16. We have assigned the material to the mesh. load, we have only specified one boundary condition. We need to specify another boundary condition also. Just double click here. Here we need to specify exchange is nothing but convection. Edit. We need to choose group of element where we need to apply convection. The top edge, here it is chosen. Say OK. There are two property we need to specify. One is heat transfer coefficient, another one is external temperature. Go to the case. Heat transfer coefficient is 50 and external temperature is 40. Heat transfer coefficient is 50 and external temperature is 40. Just save OK. Just apply it. Now see, the second boundary condition also added here. Here. Now just save OK. Now we have done the applying boundary condition. Now we need to check the solver. This is a linear solver, linear thermal solver. We need not to modify anything here. Just apply and save OK. Now output also we need to modify anything. Just apply and OK. Now we have done of creating the setup for thermal analysis. Now we can solve this file. Go to history view plus change into 5 seconds. If you want to change the memory also, we can change. This is simple case, it will not take much time, and memory also doesn't require much. So just run the case. So the operation need the study directory, so you should have study before executing this operation. Save. We need to save this. It has to save the file. I have saved the file. Just run the case. Where we have saved this file, here it will create the folder and it will solve the case. This is mesh file, script file, message file and command file. We can edit this command file also. From that we can rerun we can rename it. This is the command file for solving the case. We can use this mesh file and command file. From that from ASTK we can run it also. Now we'll check this. Now it is solved without any error. Here we can see it. Diagnostic job is okay. Now we can move into paraview for post processing. Just save this one. Go to paraview. Just right click here. Just navigate the file. This is my output file. Just save OK. Just apply it. Now just go to here solid color. Our result is temperature. Choose this temperature. Now this is the temperature profile for our case. So to change this color pattern in different color, we can view it. For example, if you want to see it in blue to red rainbow, just apply it, close. So this is the way temperature heat conduction will happen. Here this convection is happening. This temperature is very closer to this, because of that here the temperature is more. Here make it 12. So this is the way wave like this it is getting conduction. Conduction is happening. If you want to plot how the heat loss, heat drop is happening along this vertical line, we can go for filter, search. There is an option called plot over a line. Just press enter. It will show line. We need it in y-axis. Just keep it here. Now we can plot how heat transfer, heat drops happening in this location. Just apply it here. Now just scroll down here. Only temperature. Here we can make it as y points. The total height y is 0.4, 0 to 0.4. The temperature is drops happening from 300 degrees Celsius to 180 degrees Celsius. This is the way temperature drop is happening. Similarly, we can plot it here also. In this, we have completed up solving heat conduction problem using code aster. Thank you for watching my videos. Please subscribe my channel for more videos. Thank you.